Okay, so let's take a look at these logarithms that we've been looking at recently. And before we get into that, I know written down this example before, but it really helps us illustrate this point. If I have this equation right here, 5x equals 10, and I want to solve for x, what I have to do is I have to divide by 5. Now, most of us see that, and we get x equals 2. Why do I do this? Well, my problem is I want to see what x is equal to, but I know what 5x is. In order to isolate the x, and I have to undo this operation right here. Right here, it's multiplying the 5 times the x. So I divide it to get rid of the 5. Division is the inverse operation of multiplication. So when I perform the inverse operation of this 5 times x, I get rid of the 5. Fast forward to today. Now I have 5 to the x power equals 10. Well, now I have to do the same thing. I have to take the inverse operation. Now, a lot of you have been pretty creative in thinking about what exactly it is you have to do. We're not dividing here by 5 because remember, division is the inverse of multiplication. So I have to do the inverse operation of an exponential function. And quite simply, the inverse of an exponential equation or an exponential function is a logarithmic function. So I took the log over here, so I'm going to have to take the log on the other side of the equal sign. Remember to keep that balance in the equation. Now I wrote log base 5. Why did I write log base 5? Well, in my exponential equation, 5 is the base for the exponential. So here, 5 is going to be the base for my log. Now remember my power rule, where all I have to do is rewrite this as x log base 5 of 5 equals log base 5 of 10. And now all I have to do is say, oh wait, this right here is equal to 1. So I have that x equals log base 5 of 10. And that's my answer. If I want to get a decimal approximation, I can do so by changing the base. I'll have a different video up on the website for that, so you can take a look at that. But this is the important part right here. Actually, algebraically finding x. Now, say for example, I have log base 3 of x equals 7. And I need to find out what x is. Now the problem is, right here, I have the log of x. So I'm going to need to take the inverse operation of a log. Well, the inverse of a logarithm is an exponential. So here I'm going to I'm going to make this an exponent of 3. But what I do to one side of the equal sign, I have to do to the other. Now this, just as before, where I have a logarithm with the same base, this is going to cancel out. So I'm left with x equals 3 to the 7th. And I can't think of what that is off the top of my head, but again, I get some calculator and figure out what x is. The important part is I understand I'm doing the inverse function here, the inverse operation. For reference, all of this happens the same way with your different logs. Don't be intimidated when you see natural log of x equals 5 and you think about what you have to do. Here we can see quite clearly the base of this log is 3. Well, over here, what's the base of natural log? Yep, the natural base, e. So I make both sides the exponent of e. This cancels, so I get x equals e to the 5th. what if I have e to the third power equals 7? Well, just as before, where I had over here, I needed to take the log base 5 of 5. Here, I need to take the log of this exponential function with base e. But remember, I don't write log base e, I write natural log. And I have to do it to both sides. So it just says log base 10 of 10, or log base 3 of 3 equals 1. Log base e of e, or the natural log of e, equals 1. And with my power rule, this will drop down. So I get 3 equals... Oh, I'm sorry, there really should have been a variable in here. That should have been 2. That should have been an x up there. So I get x equals the natural log of 7. And again, same deal. I get decimal approximations for these, and I just put them in my calculator. All right. So I'm going to be posting some more videos, so be sure to check them out. But in the meantime, just keep working, and any questions?